So in this video, we are going to see a problem from exercise 8.1. Okay, problem from exercise 8.1. So it's question number 5. Let's read the question. Given sec theta is equal to 13 by 12, calculate all other trigonometric ratios. So we are given one trigonometric ratio and we have to calculate the remaining 5. Total we have 6 trigonometric ratios. So let's first note down the standard definition of sec of theta. Now remember, this theta stands for an angle. So typically till now we have seen like sine of A. We have seen something called as sine of A or cos of B or tan of C, something like that. So instead of this ABC, we are using some another Greek symbol which is called as theta. There's nothing to get confused about it. Okay. So sec of theta is equal to 1 upon cos of theta, and that is equal to hypotenuse the whole divided by adjacent side to angle theta. Okay, that is very important. Adjacent side to angle theta, which translates into, okay, first of all let's clear this mess, which translates into, let's draw a triangle with theta as the angle. So this is my right angle triangle. Okay, and we have this. So let this angle be equal to theta. Okay, now let's come back to our definition. So this is going to be the hypotenuse. Okay, let's name the sides. So let's name them as A, B, and C. Okay, so what is our hypotenuse in this case? In this case, hypotenuse is AC, the whole divided by, what is the adjacent side to angle theta? Adjacent to angle theta is AB. BC is opposite, AB is adjacent. So that is equal to AB. Yes, and this value is equal to the given 13 by 12. It is given that sec of theta is equal to 13 by 12. So sec of theta is equal to 1 upon cos of theta is equal to this definition is equal to AC by AB as per this random example of triangle we have taken, and that is equal to the given value 13 by 12. So let's make a note of that, 13 by 12. So thus we have finally AC by AB is equal to 13 by 12. Okay, so now let's draw a line here. So now let me zoom in. Yes. So so let K be common factor. Let K be the common factor between these two sides, AC and AB. Okay, so since this is a ratio, we want to find the length of the sides of all these three sides of a triangle. Once we have the length of sides of all the three sides of a triangle, we can find all other trigonometric ratios very easily. So that's what we are going to do. So let K be the common factor between AC and AB. So we have AC will be equal to 13K and AB will be equal to 12K. Okay, in fact, let's make a note of it. AC is going to be 13K and AB is going to be 12K. Now we have to find what will be BC. Okay, now that is done by using our Pythagoras theorem. So let's come here. Okay, so using Pythagoras theorem, we have AC square as equal to AB square plus BC square. Now what is AC square? It is 13K the whole square, that is equal to, what is AB? It's 12K the whole square plus BC square. So BC is what we have to find out, and therefore I am going to rearrange. BC square is equal to 13K square minus 12K square. Okay, now here we are going to use the identity. Okay, I don't have a space, but here I'm going to, let me draw a line here. Yes. So I'm going to use the identity. The identity A square minus B square is equal to A plus B into A minus B. Okay, this is our standard identity. So I'm going to use this to expand the right hand side of my equation. So let's go ahead. So that is going to be equal to 13k plus 12k into 13k minus 12k. Okay, very straightforward. So 13k plus 12k is equal to 25k into 13k minus 12k is equal to k, and therefore we have bc square as equal to 25k square. Now I'm going to take square root on both the sides of the equation. So that's going to give us bc, which is equal to under root of 25k square, and that is equal to 5k. Thus we have got bc as equal to 5k. Let's make a note here. Now we no more have this question mark. I'm going to erase this question mark, and we have bc as equal to 5k. Now thus, if you zoom in and look at this triangle, we have all the three lengths of the triangle known to us in the form of k, but that doesn't matter. 13k, 12k and 5k. Now using this, we can find rest all the other trigonometric ratios. So what I'm going to do is make a copy of this triangle. Oops. Copy and bring it down. Let me bring it here. Paste. Okay. And now we are going to find the ratio of all the we are going to find all other trigonometric ratios. So here it is. Okay, we are going to start with sine. Now we have to, now the angle is very important. So the angle is theta. Okay, so remember that the angle is theta. So let's start with sine of theta. Now sine of theta is equal to side opposite to theta, the whole divided by hypotenuse. And now in this triangle, what is the side opposite to theta? BC. So let's make a note of that. BC divided by hypotenuse is AC. But what is BC? It is 5k divided by 13k, and that is equal to 5 by 13. So that becomes our sine of theta. Now let's continue and let's go with cosine of theta. Cosine of theta is equal to side adjacent to theta upon hypotenuse. But what is the side adjacent to theta? It is AB, which is equal to 12k. So first let me write down AB divided by hypotenuse is again AC. But what is AB? It's 12k. What is AC? It's 13k. That's equal to 12 by 13. Okay, so 12 by 13 is our cosine of theta. Now let's go to tangent of theta. Tangent of theta is equal to side opposite to theta, the whole divided by side adjacent to theta. Okay, now side opposite to theta is BC and adjacent one is AB, and that is equal to, once again, BC is 5k and AB is 12k, so that is equal to 5 by 12. So thus we have calculated sine of theta, cosine of theta and tangent of theta. Now the rest of the three trigonometric ratios are nothing but a derived trigonometric ratios. So you don't have to calculate it again looking at the triangle. They are derived from these three itself. Let's see how does that go. Now cosecant of theta is nothing but equal to 1 upon sine of theta, 1 upon sine of theta. This is by definition. But we already know what is sine of theta. Sine of theta is 5 by 13. So 1 upon sine of theta is going to be 13 by 5. So I'm going to just write it down, 13 by 5. Now we go come to secant of theta. Secant of theta was actually a given value. Okay. Secant of theta was a given value, 13 by 12. So I'm just going to note it down. This was 13 by 12. 13 by 12. And last, cotangent of theta is nothing but it's 1 upon tangent of theta. So it's 1 upon tangent of theta. We know what is tangent of theta. Here it is. Tangent of theta is 5 by 12. So we just need to find the reciprocal of it. That is equal to 12 by 5. And thus we have calculated all the trigonometric ratios. All the trigonometric ratios of from this given information where sec of theta was equal to 13 by 12.